So can we give Justin a round of applause, please?
Thank you very much, Luke. So I'm really excited to share with you today some thoughts and feelings I have on the security of software development software. So a little bit about me. I'm an application security dude, so I work with doing source code review, static and dynamic application security assessment, things to do with bugs and vulnerabilities and exploits. In my spare time, I enjoy playing CTFs, finding bugs, and attempting to occasionally write exploits. And these days, very seldomly do I stream on Twitch. But when I do, it's a lot of fun. I stream kind of the live solution of CTF challenges and binary exploitation stuff. It's a lot of fun. I'd like to stress that I'm not a developer, nor have I ever been, nor am I an operating adversary, a pen tester, or a red teamer. So I do have some thoughts to share on both of these worlds. Things like how is software development software sometimes insecure or vulnerable? And I've got some thoughts on how this might be used to harm or compromise a company, but I don't kind of have the experience from there. This all comes from the more application security background. Also, this is not like a SecDevOps talk. This is not how to secure your organization's software. It's more about bugs in tools that are used to build software. So maybe you'll be happy about that, maybe not. Oh, it's kind of cut off. That sucks. But this is me. I've got this really bad habit of breaking my own tools. So I'll be doing work and I'll get kind of bored and think about how can I exploit the software that's used in my own tool chain. And if you're getting started with vulnerability discovery and bug hunting, I'd encourage you to start with the tools you're familiar with or the tools that are used in your industry. You kind of get that home team advantage. You know the software already, and also it helps you reason about the attack surface of you, your colleagues, your industry. So it's a really good place to get started. So what will we cover today? We'll start off with what do I mean when I say software development software. We'll have a quick chat about why I think people who use this software are particularly interesting targets. We'll then walk through the discovery and exploitation of vulnerabilities in two different pieces of software. And we'll close with, is this a risk? And if so, what sort of things can we do about it? I just realized my slides are super cut off. This is going to be fun. So when I say software development software, what I'm talking about are the tools used to build software, the tools used to write, compile, and deliver software. Oh, this is super cut off, that's awesome. So the first set of tools I think about when I think of this type of software is your IDE, or your integrated development environment. What can I do to fix this? Oh, come on. That'll do. So your IDE, it's kind of like a fancy text editor. It's a source code editor with syntax highlighting and other quality of life aspects to it. But then there's also a bunch of helper tools. And these are the little bits and pieces that kind of support your software development activities, such as running your tests, pulling in third-party dependencies, pushing your source code to shared source code control, all those little bits and pieces in your tool chain. And then there's the CI/CD software, or the build pipeline software, that runs on a centralized server, tests the software, builds the software, and often these days deploys it to production. So in an organization, this is kind of what that looks like for those who may not be familiar. Up the top, we have our developer workstation. Our developer, the bread and butter tool, is an IDE in which code is developed and pushed into a Git repository. The code then flows to the build pipeline, where it's built, tested, and then, in many cases these days, shipped straight to production. And there's also this cheeky little back channel as well, going from the developer workstation straight to prod, and we'll talk more about that in a moment. So today, I'm choosing to focus on the developer workstation and thinking, how could an external adversary compromise a developer's workstation based on vulnerabilities in developer tools, and what could happen from there? So if we think of these tools in kind of this sort of flow, this is something that many people here are probably familiar with, where you pull down some source code off the internet, you CD into that directory, you read the code, hopefully you read the code, build the code, and run the code. And if we think about the ways in which this can go wrong for us, there's a pretty clear way in which something could go bad, and that's when you run the code. If you've just pulled any old nonsense off of GitHub, built it, and run it, there's a chance that there's malware in the code or some sort of malicious activity that will compromise your workstation. But if we start to step back through this process and look at the tools involved at each step, there are other surprising attack surfaces. For example, building software. Maybe you were considering building the software but not running it and thinking that was safe. Well, in many cases, the build script or the build manifest, such as a makefile, can actually have malware embedded directly in it. I mean, a makefile is just a fancy shell script, changed my mind. So there could be kind of anything in there that'll just download and run some sort of payload. So that's not necessarily a safe action. What about reading the code? Well, I mean, we've never had bugs in document viewers, right? So surely viewing text files in an IDE is safe. Well, we'll dig into this a little bit shortly. And how about CDing into a directory, like in a shell? Like, surely CD is pretty safe. Well, some developer tools actually hook in to your CD and do things based on the directory you're CDing into. And we'll dig into one of these as well. And finally, the Git clone. There's been a history of vulnerabilities in the Git client itself, so that can be enough to get you owned. So as I said, we'll be kind of drilling into these two steps in particular today, but there's a lot of kind of surprising attack surface when you start to pull together the tools involved in something that might be fairly routine to you. So we've covered what do I mean when I say software development software. Let's take a minute to think about why would we want to target someone who uses software development tooling. There's the kind of obvious case to me of intellectual property theft and the confidentiality of source code. But what might be surprising to some is that in at least some, if not many organizations, there's a kind of culture of openness among the staff. So there's discrete development teams, but it's often the case that any one development team has at least read-only access to the entire company's source code, or at least a large chunk of it. So if you're able to, as an adversary, compromise one software developer, you can at least get read access to all the source code, pull it down. That could be what you're after, kind of an economic or intellectual property impact. But you could also then start to read the code and look for bugs and then move across and attack production systems. So the confidentiality of code is one reason to target developers. Let's see if we can realign these slides. There we go. How about the global supply chain, right? This has been pretty hot the last couple of years. It's only going to get hotter. But if you can compromise a developer at an organization, there's the integrity aspect. You know, can you modify the code to introduce malicious functionality or introduce vulnerabilities? Or could you modify the build process and the build infrastructure to start to kind of, at compile time, put malware in the builds? In an era of DevOps, it's often the case that developers are systems administrators, at least for the systems that support the software that they write. So if you find yourself on a developer machine, there's a lot of things I think you would find interesting, but take, for example, the shell history, SSH key, and the AWS credentials. This could be enough to be starting to give that organization some heartache and a pretty bad day. So it's often the case that developers have access to production infrastructure so that they can support the deployment and operation of their software, and that makes them pretty good targets as well. So that's what do I mean when I say software development software, and why are some of the users of this software particularly interesting targets? So I'd now really like to walk you through how I stumbled across some vulnerabilities in software development software, and the process by which I understood the vulnerability and produced a proof of concept exploit for them. And we'll start off with Ruby Version Manager. So Ruby Version Manager is, first of all, it's not part of the core Ruby product. It's a third-party kind of in the Ruby ecosystem tool, but it's a very popular tool. And what it's used to do is it's used to support multiple versions of Ruby on a developer's workstation. And funnily enough, the Metasploit development environment setup guide recommends that users or developers install either RVM or RBEnv. They're both a very similar tool. So there's a lot of exploit developers out there in the world with potentially RVM on their machines, which I think is kind of interesting. And how does RVM work? When you install RVM, it pokes itself into your shell profile, so that every single time you launch a terminal or launch a shell, RVM is loaded into that shell. And from then on, when you CD into a directory that is a Ruby project, RVM kind of pokes its head out and says, hey, it looks like you're CDing into a Ruby project. Do you want to install the version of Ruby that this project requires? So it's kind of like the Clippy of the Ruby world. And it helps you install that version of Ruby to your home directory. And from then on, every time you CD into a Ruby project, kind of magically and behind the scenes, RVM will like stitch up your environment so that you're using a different version of Ruby in your $path. And it's kind of magic how it does this. And magic things can sometimes be interesting. So for a while I was thinking to myself, I wonder how RVM does this. How does RVM know when I'm CDing into a Ruby project, and how is it kind of juggling things in my shell to change the version of Ruby that I'll be running? And then I proceeded to not look into it for quite a while, until one day I was doing some shell scripting, and I had turned on the set -x option in my shell. And the set -x option, what it does is every time your shell does something, it kind of prints a line, and it's a trace of every single thing happening inside Bash in the course of processing that thing. So then I did CD to some directory, and normally, set -x would show one thing, I'm doing a CD. But on this day, it pooped out a whole bunch of stuff. It pooped out a whole bunch of internal RVM stuff. And at first I was kind of a bit shocked, and then I was a bit happy about this. I realized that RVM was hooking CD, and every time I ran CD in my shell, which I do quite often because I seem to think the terminal makes you faster, it probably doesn't, but anyway. Every time I was running CD, RVM was behind the scenes going, where are you going? What are you doing? Is this a Ruby project? Can I help you with this? So I started digging through the code. So I grepped for kind of .ruby version, which is, I know, one of the metadata files that Ruby uses to specify, or a Ruby project uses to specify which version of Ruby it's looking for. And I came across this chunk of code, and hopefully that's readable. If not, all these slides are already online, so don't stress too much. And in the handling of the .versions.conf file, I noticed there was some sort of section that was dealing with environment variables. So I thought to myself, okay, if a versions.conf file can specify environment variables, can I poke random stuff into someone's environment if they CD into a directory with this file in it? So then I kind of sprinkled fairy dust all through the code, all these little debug print statements so that I could follow the bouncing ball and make sure I was kind of tracking through the code and looking at the right thing. This is really good if you're like me and don't know how to use a debugger. Just print, I'm here, all through the code and follow the bouncing ball. And I ended up in this region of code that was actually handling the contents of the .versions.conf file. And I saw down the bottom there that there was a export something equals something, which suggested that yes, indeed, I did have the ability, based on the versions file, to put arbitrary stuff into the environment of the process that the shell was running in. And I also thought eval, that's kind of interesting, because if I could get a backtick or a dollar bracket into the string that was getting evaled, I'd have two vulnerabilities. And earlier in the bouncing ball of the code, there was a line that was attempting to sanitize the contents of the versions.conf file. What it was doing was it was looking for backticks or dollar bracket, and it was dropping a backslash in front of it to escape it. But what it wasn't doing was it wasn't putting backslashes in front of any of my backslashes, which meant that if I put my own backslash in front of the dollar bracket, then RVM would put a backslash in front of the dollar bracket, and the two backslashes would cancel each other out. This is a classic vulnerability for anyone who's dealt with exploiting SQL injection bugs that have a poor escaping engine put in front of them. So let's quickly have a look at these two vulnerabilities and what they actually look like when you're kind of exploring the concept and then exploiting the vulnerability. So we've here got a Docker container running an old version of RVM. If we just make a POC directory and hop into it, and then create a .versions.conf file, and set the Ruby version to be system so RVM doesn't complain. And if we then do environment, foo equals bar, save that, nope, save that. And if we then cd, actually we'll just quickly, nothing up the sleeve, echo $foo. The foo environment variable is currently not set. If we just cd into the directory we're already in, it will trigger RVM, $foo. We can put whatever we want in the foo environment variable. So this is that bug number one, where we get arbitrary environment control. So from here, I know there's at least a few ways to go from environment control to code execution. And the avenue down which I went was to set the PS1 environment variable. PS1 is normally kind of like this format string that specifies what the user's prompt should look like. So they can put the time, they can put the date, they can put their username, and you can customize your own prompt. So if we set someone's environment variable PS1 to be the old value of PS1, followed by $ID, we will run the ID command. Now, RVM is going to come along and sanitize this. As I said, it'll put a backslash in front of that dollar bracket, but that doesn't matter. Because when bash evaluates its PS1 environment variable, it will do a second layer of shell interpolation, and even though that backslash will be there, it'll still pop anyway. So if we save that file, cd out of the directory, cd back in, you can see we can run arbitrary commands as soon as someone cds into our directory. So the second bug, the backslashes. If we go back to, I'm just commenting these out, by the way. If we go back to the foo case, and we go, bar dollar bracket ID, RVM is going to put a backslash in front of it, and that will result in it being escaped. So if we have a quick look at what this would look like, cd dot echo dollar $foo, then it's literally dollar bracket ID. We don't get that eval injection we were looking for because RVM is putting that backslash there. But if we put our own backslash there first, when RVM puts another one there, the two backslashes, the first one will escape the second one, and the dollar bracket will survive. So let's just leave one of those backslashes in, save the file, echo dollar $foo, and we've got another opportunity to inject arbitrary commands as soon as someone CDs into the directory. And the user doesn't need to actually echo foo for this to pop up. Like if we just go and shove this into standard error, cd out of the directory, and cd into it, we can run arbitrary commands as soon as they cd into the directory. So a quick recap. Kind of started off with a bit of a hunch and a bit of, breaking my own tools and thinking, how does RVM actually achieve this rewiring of the rubies on the fly based on me CDing around my file system? And I was like, oh wow, that is a lot of set minus X output. It's obviously hooking CD and doing a lot of things behind the scenes. So I grepped the code to find where it was parsing these files, and then followed the bouncing ball through the code to find the eval injection and the arbitrary control of the environment variables. So moving on to Visual Studio Code. Visual Studio Code is an IDE. It's a really, really fancy text editor, syntax highlighting. It has integration with a debugger, which I should probably learn how to use. It's got integration with a compiler, and it's got all these nice things that make cutting code much more pleasant than just using Notepad. So one day I was reading the VS Code documentation. As I do, I don't get out much. And I saw that VS Code had a feature called workspace settings. And the workspace settings allowed a development team to all agree on tabs versus spaces through a configuration file that they checked into their code project. So that every time anyone opened up that code project in VS Code, some settings would be applied automatically so everyone was on the same page. And this reminded me of a bug that was a little bit before my time in Vim. So Vim has this thing called mode lines that I think are disabled by default now because of stuff like this. There was the ability to put special comments into a text file or a source code file, and whenever you opened that file up in Vim, it would help the team agree on tabs versus spaces and so on. It would reconfigure parts of Vim for that file. And then some people found out that there was the ability to run arbitrary code when you just opened up a text file in Vim, which is awesome. And so I think this got disabled by default, and this bug, I'm sure, got patched. But I thought to myself, if Vim had this error up until 2002 or so, what about VS Code? That's a lot of attack surface in the reconfiguration of an application based on a text file in a code project. I wonder if there's any dangerous knobs or dials I could turn based on that file. So I had a look through the settings that you could reconfigure based on the workspace settings within a code project. And I saw that there was the ability to reconfigure the path to the Git binary. And Git is the client software that helps you push and pull code from code repositories. And I knew that VS Code heavily relied on Git. It would actually run Git every time I opened up a code project, because if I opened up a Git-based project in VS Code, I got all these decorations and history markings and stuff, and I knew that Git was being run by code. So I thought this was a pretty interesting avenue to explore. So I started off by reconfiguring the Git path to be the string ZZZZ. And then I ran I ran VS Code under strace to look at all the system calls that were being made by VS Code. And this allowed me to see all of the child processes that were being kicked off. And I saw that VS Code was trying to run the program ZZZZ in my path. I then threw a whole bunch of spaces and meta characters and semicolons and dollar brackets thinking, can I just like straight up put like a shell one-liner in here and just execute whatever I want? But strace was showing me that no, my path was being walked to try and find a binary, literally called this mess of characters. So I wasn't reaching like a system-style sync, I was reaching an exec-style sync. And this was really important to notice, because otherwise I risked just jamming a shell one-liner in there, popping VS Code, going, it didn't work, and moving on to play Fortnite or something. But by understanding the primitive I was working with, I knew that the reason why nothing would be happening was not because there wasn't a bug, but because I wasn't holding it properly. So I set the git.path to be true, which according to the man pages does nothing successfully. And I saw that VS Code was running true -- version, true rev paths, true status, so on and so forth. These are all git subcommands that you'd normally do, like git rev paths, git status. But instead, VS Code was using the true binary. And when I set the git path to be false, which according to the man page does nothing unsuccessfully, it was only doing false -- version and giving up. So I could see that if any of the attempts by VS Code to run Git using the path I told it to, if any of those attempts failed and it got like a non-zero exit status back, it would give up and go, I'm not going to try and run Git anymore. And the last thing I did was wrote a small, terrible shell script that whenever it was run, it would log to a file how it was run. It would log the arguments given to it, and it would log the directory from which the process was executing it, or the CWD or PWD. And I saw that the -- version was just being done from wherever the user was sitting in their shell at the time. But the rev parse argument, and only the rev parse argument, was being done from the directory that the source code tree was in. So that was also fairly interesting. So this is what I was working with. VS Code was doing something -- version where I can control the something based on this config file. And if that succeeded, it would then do a CD, a chdir, into that directory, and then it would do my something, rev parse. Did it succeed? If so, keep going down the rabbit hole. If not, give up. So I wanted to do two things. I wanted to do something naughty, and I wanted to do something naughty before a non-zero exit code was returned by the subprocess attempt. Otherwise, the chain breaks and I can't do my naughty stuff. And I thought, what if I set the Git path to be bash? Because then VS Code will do bash -- version. Will that succeed? Turns out, yeah, bash -- version returns 0, like 2 thumbs up. Because then VS Code would do bash rev parse from inside the directory with all the source code in it. At which point, if I've got a shell script there called rev parse, bash will be used to interpret that shell script, and then I can run whatever shell commands I want and drop a Bitcoin miner or what have you. So let's have a quick look at what this looks like. So here I've got another Docker container running an old version of VS Code. By the way, those RVM bugs got patched, and this has also been patched. So we've got an old version of VS Code. We'll make our POC directory, cd into it. We'll make our .vs code directory, which is a directory within which the settings file has to be. And we'll edit the settings.json file inside that directory, which is these workspace settings. We'll set the Git path to be bash. And we'll create that rev parse file. And that rev parse file is the file that will be run within bash. So we'll do the classic open up a calculator, and then we'll echo, code execution as the user to a file called win, and then we'll exit one. If we exit one, that will break that chain of VS Code trying to use bash instead of Git. So what have we got? We got this settings file that says, hey, VS Code, don't bother using Git, use bash instead. And then we have this revparse file, which will be run by bash when VS Code is attempting to use bash instead of Git. So if we open this code tree or this directory up in VS Code, we get the calculator, and we get a file on disk. I should have checked if it existed before. I promise you it didn't. So we deleted the file, calculator pops up, and our temp win file is there to show that we can execute whatever we want at this point in time. So another quick recap. What did we do? It's kind of started off with a hunch, reading the documentation, which, by the way, is actually a really good way to find bugs. A lot of the bugs in the world aren't actually bugs, they're features just used interestingly. So it started by reading the manual and saying, wait a minute, what are these workspace settings? Didn't Vim have a problem with this a while ago? And then understanding the primitive and using strace to kind of have a peek at what's going on under the hood when VS Code tries to run Git, and then kind of understanding that primitive more and more and more, and then mapping out the flow and thinking, what could I set the Git path to achieve arbitrary code execution? My solution ended up being bash. There's probably others. And this is all done on Linux, by the way, because, again, I'm annoying and break my own toys, and I use Linux like a crazy person. So putting it all together, these two bugs, the little proof of concept of editing a text file and CDing and seeing stuff pop up is, I think, interesting. But what would a more real-world attack look like? Could we convince some victim to obtain some source code? Maybe we say, hey, you should clone this using Git. And then expect that they'll CD into that source code tree and then maybe use Visual Studio Code to read the code that we've just suggested that they clone. So we've got one last demo to show what this might look like. So now we've got two Docker containers. On the right-hand side, we've got the attacker container with 4 different windows open. On the left, we have a victim container. The attacker's running 3 different Netcat listeners because we're hacking like it's the 90s, and just one little Python web server to serve up the source code. And the victim receives an email suggesting that the victim clones a source code project using Git. So let's say the victim clones that using Git, and we get some sweet ASCII art that gets cut off. There we go. This is not my bug. This is a Git vulnerability from last year, in which if you Git clone stuff recursively, a vulnerable version of Git will just straight up, in some cases, run arbitrary code based on like a crafted Git repository. And up the top right here, the attacker's received the first of 3 reverse shells. So then the victim goes to CD into the directory of code that they just cloned, totally not malicious. And if we watch this Netcat listener here, we get another shell, and that was just RVM hooking CD, and there being a malicious file in that directory. And finally, the victim then launches Visual Studio Code against that directory of source code, and the attacker gets the 3rd and final shell. And these don't have to be shells. They could be, dropping some sort of rat or dropping some sort of payload or dropping, as I said before, a Bitcoin miner. But it's an opportunity through which an attacker can convince or try to convince a victim user running these vulnerable versions of software to clone some code and then just operate with it in seemingly innocent ways. You're just CDing into a directory. You're just opening it up in an IDE. But these actually have, in some cases, surprising attack surfaces and hence vulnerabilities. So a few closing thoughts. How am I for time, Luke? 10 minutes? Awesome. A few closing thoughts. Is this actually a risk? I think so. I don't think my trash bugs are really that much of a risk. I think they're cool bugs, but they're pretty noisy attacks, and you're relying on the victim actually having a vulnerable RVM. I don't think my bugs would be used in any sort of attack, but I think attacks of this nature are certainly possible, and they're actually happening. Last year, ForcePoint did some research and saw that there were malicious AutoCAD files being sent to some industrial designers for the purpose of stealing more AutoCAD files to put malware in to send to other victims. So there's already instances of industry vertical software or vertical specific software and bugs in that software being used in campaigns to attack industry. Earlier this year, we had the delight of finding out about Shadowhammer and Kaspersky showing that Zeus had been compromised and was sending out malicious firmware update, not firmware, malicious updates for Windows software. This was kind of cool. What I thought was super interesting was something we found out about just last month, in which the same crew are suspected, or Kaspersky is saying that they have either compromised a few games companies, or those games companies downloaded a cracked version of Visual Studio put out by the Shadowhammer operators that has a compromised compiler. Like, this is the old Ken Thompson attack. And this compromised compiler on the developer workstation, when they built the video game to then publish to gamers, at build time, it included malware. And I just think this is really interesting. It's a real-world case just last month of software developers being attacked as part of a very targeted supply chain style campaign. I just think backdoored compilers are awesome. So what can we do about this? What can we do in particular about vulnerabilities in software development software if we think it's something to be concerned about? I think the most important first thing is, especially for developers, to understand the tools that are in your personal pipeline, understand how internet data might be exposed to these bits and pieces in your data processing flow. Have a think about, IDEs, they're very, very powerful tools. I perhaps wouldn't use one to look at code I did not trust, because IDEs have built-in debuggers and compilers, and they're only one click away from running code, but there might be some attack surface in there that leverages that sort of power to run malicious code on your machine. And of course, patch. It's super important to patch all the little bits and pieces and bits and bobs in your software development toolchain. Consider RVM. I don't think RVM has automatic updates, so any Ruby developers who haven't updated RVM for a few years have these sweet CD bugs still in their environment. So make sure you're on top of patching of all the bits and pieces in your toolchain. And I think there's a case to be made for some sort of containerization or sandboxing of our workflows. Let's say let's take me for example, I'm doing a secure code review. And sure, I probably trust the code I'm reading, but I kind of also, having found a bug like that one in VS Code, I don't want to open things in VS Code on my workstation. So like the crazy person I am, I run the Visual Studio Code inside Docker. And Docker's not necessarily a full security story, but if you're interested in giving it a go and running your tools in Docker, I think it's a really interesting way to provide isolation of your different work contexts. It's kind of like a lightweight Cubes OS, which is also something I should probably look into one day. But it just kind of helps you, have an ephemeral working environment. You open something up in something like VS Code, and then when you close it down, it's gone. And the next time you open up VS Code, it's done fresh from a Docker image. And it prevents persistence across days. It's kind of like wiping your machine at the end of the day. There are caveats to using Docker for security. Docker doesn't really, I think, claim to be having a full security story, and there's always going to be Docker escapes, but I think it is markedly better than running it directly on your host, as long as you're not running it in root in the container. But there's this one really annoying thing when you're running Docker on Linux. Well, there's a lot of annoying things about running Docker on Linux, but one in particular is to get graphical applications to work, you have to expose your X socket into the container. And there's some really novel ways to crawl back up through an X exposure to the host. If you want to know more about that, Metalstorm has an awesome video on YouTube with that and tons of other Unix party tricks that is well worth a watch. The traditional advice applies, security monitoring, make sure your developer workstations are being monitored and patched and all that good stuff. Two-factor authentication, make sure developers, when they're hopping around via SSH or using Amazon keys, that they're required to kind of touch base with a 2FA system occasionally to have those keys operate. All the kind of good standard stuff. But the monitoring can be a little bit tricky with developers. Developers love to BYOD and have full control over their machines, and they hate using IT machines and are bogged down with security agents. But it is really important to kind of make sure you are monitoring in some capacity your developer workstations. And have a conversation with the development teams and say, hey, help us to understand what would be the impact to the organization if your workstations got popped. Put it this way, if you were to turn rogue tomorrow, based on the credentials and the access that you have, what damage could you do? And don't go into this looking to strip permissions away from developers, they have jobs to do, but go into it to understand, exactly what could the impact be if your workstations were breached. And finally, I think it'd be really interesting to do some sort of red team engagement where you drop the red team onto a developer workstation or a replica of a developer workstation and say to the red team, hey, how far into the environment can you get from here? What sort of exposure are we at from our developer workstations? And if you think this is a bit scary, if you think there's no way I could really give the red team such a head start and there's no way they might break something, that probably says everything you need to know about how important the security of your developer workstations is. So that's what I have to share today. Thank you very much. If you want to @ me on Twitter, you can. If you want to watch me live on the internet when I never stream, you can. The slides from today are up on my GitHub, and there's a few more RVM bugs I didn't have a chance to show in my advisories repo. So if you're curious, check those out. And questions, I suppose?
Thank you. That was fantastic.
Thanks, dude.
It is scary stuff, honestly.
Does anyone have any questions? I reckon this will work in Windows as well. Have you tested it out?
No.
All right,
I haven't.
we'll have a chat.
Yeah,
I'm
sounds
a
good.
Windows fanboy, so. So if there aren't any other questions, we might just call it there.
Easy.
Right, yeah. Thank you very much, Justin.
Thank you,
Another round of
everyone.
applause, please.
And you get the best speaker prize ever.
Beauty. Thank you very much.